All right. Well, hello and welcome to Solar Alberta's 2025 Solar Show, our 11th annual. Today's session is called Intro to Solar Energy Storage in Alberta. Please note that we have enabled closed captioning for this presentation. You can turn the captioning on in the toolbar at the bottom of your Zoom screen. We will be recording this session and making it available on our website and YouTube channel later, probably in about a week or two after we've edited it. My name is Heather McKenzie. I'm the Executive Director at Solar Alberta. I'd like to take a minute to acknowledge that I'm hosting you today and working day to day from Amiskwaciwaskahigan, also known as Edmonton, Alberta, Canada, which is located on Treaty 6 territory in the homelands of the Otipemisiwak Métis Nation. Treaty 6 territory is the traditional gathering place and home of many Indigenous peoples, including the Papaches, Nehiyawak or Cree, Saulteaux, Dene, Blackfoot, and Nakota Sioux, nations whose ancestors have cared for and nurtured these lands since time immemorial. We were delighted to have so many people register for this week and for this event in particular. To start, we'd like to thank Greengate Power for sponsoring this exciting session today. We're super happy and grateful to have them as a sponsor. Today, we're going to be hearing from Ozair Khan and Gabriel Risbud Vincent. Following the presentation, there will be a question and answer period in which you can all participate. We'll be using Zoom Q&A for questions rather than the chat box. So please enter your questions in the Q&A section. Also, please click on the little thumbs up symbols to upvote questions that you like. The entire session will wrap up in an hour. To begin, I'd like to encourage you to check out our online trade show. You can click on the link in the chat to view 10 exhibitor booths, which include a listing of key solar-related services, contact info, and video introductions. Before we move forward, we're just going to do a quick poll to get a sense of who we have joining us today. So please take a minute to answer the question popping up on your screen now. And while some are still doing the poll, I encourage you to take a minute to pop your name, land acknowledgement, any contact info you're comfortable sharing in the chat now and throughout the event so that others can look you up on LinkedIn or email you, and hopefully you can stay connected. Just going to give one more second for that poll results there and have a look at the results. Okay, interesting. So we've got quite a split today, right, between the solar industry professionals and the solar curious. So this is going to be a challenge for our presenters because they're going to be speaking to the general public and industry professionals alike. And looks like we've got a lot of microgenerators in the house too. So welcome. I hope you're considering adopting some storage to go with your arrays. And thank you all for joining us today. Now, I will take a brief moment to share a little bit about us. Solar Alberta is in its 34th year of operation. We're a nonprofit society that is dedicated to accelerating Alberta's transition to a just and sustainable energy future. We do so by advocating, educating, and serving as an industry and community hub for solar energy. Our membership is made up of over 220 individuals and 160 businesses. We also have over 31,000 followers. We provide a number of services, including managing a solar directory through our website. In this way, we act as a bridge for installers, suppliers, and other solar-related businesses to connect with their customers and clients. Our directory gets over 48,000 hits each year, and you can see a link to it in the chat. We are once again offering affordable courses for solar industry professionals or those looking to transition into the sector. Most of our courses are online on Tuesday and Thursday evenings. First up is Solar PV Systems Design and Modeling. That starts this coming Tuesday, February 11th. And on the first weekend in April, we are also offering an in-person course in Calgary, Solar PV Systems, Commissioning, Operations, and Maintenance. So we are offering our training course bundle as well. The bundle includes 3 of our technical courses at a discounted rate. That's available till February 11th. On-demand recordings of our courses are also available for sale alongside our paid workshops in the solar training videos section of our website. In addition to our courses and this solar show, we run our free solar seminar series and a number of in-person and online networking events each year. Our next solar series session is Alberta Agrivoltaics 101, Solar and Farms Unite. It will take place on March 20th at noon, and registration for that seminar can be completed through the link in the chat. We're also popping in a link for our March 11th Solar Women's Gathering as well. It's not too late to register for the 2 solar show sessions left tomorrow. Registration for each will be open until an hour beforehand. As mentioned before, we also advocate for solar. We are currently rising up for renewables. We have free lawn signs available for pickup in 10 municipalities, and we offer free delivery in 8 municipalities around Alberta. We have template letters for you to use on our website asking the Government of Alberta to eliminate the new and discriminatory buffer zones that they have established for renewable energy. You can click on the link in the chat to make a free sign order or to find our template letters today. If you're not already a member, I want to encourage you to join. Individual memberships are typically $35, but are on sale this week for 20% off. They can be purchased at the link in the chat. And if you're looking to support our work in additional ways, please consider volunteering or donating. On the topic of volunteering, we have one position coming available on our board. This position will be filled at the May 7th AGM. If you are interested in becoming a part of Solar Alberta's board, please use the link in the chat to apply by March 16th. With your help, we are recognizing longtime dedicated contributors to solar in Alberta by gifting them a free lifetime Solar Alberta membership. If you are currently a member and you know someone who has contributed significantly, then please consider nominating them for this award. You can find the link in the chat, and we will be accepting nominations until April 16th. Finally, we ask that you please consider participating in our 50/50 raffle, which is over $2,200 now. Ticket sales end tomorrow at 12:55 p.m., right as we wrap up the solar show. And now, without further ado, I'd like to take this opportunity to give another shout out to Greengate Power Corporation for sponsoring this session, and I'd like to introduce our speakers for today. First, we're going to be hearing from Ozair Khan. Ozair is the Senior Engineer of Grid Transformation at EPCOR Distribution and Transmission Incorporated. In this role, he works to support increasing electrification by conducting research and implementing projects and initiatives for EPCOR's electrical distribution system in Edmonton. Then we're going to hear from Gabriel Risbud Vincent. Gabriel is a professional engineer with 5 years of experience in renewable energy, specializing in utility-scale solar PV and battery energy storage systems. With Solus Energy, he has worked on approximately 2 gigawatt of solar projects across Alberta and the US, including feasibility studies, due diligence, development, and solar glare assessments. Gabriel has worked on energy storage market analysis and has supported the development of over 5 gigawatt hours of battery energy storage systems across North America, 2 gigawatt hours of which are currently in development. So welcome to you both, and I'm going to start by passing the mic over to Ozair to begin his presentation. Welcome, and I'll turn my mic and screen share off so that you can start yours.
Thank you so much, Heather, for the wonderful intro. As Heather mentioned, my name is Ozair Khan, Senior Engineer of Grid Transformation at EPCOR Distribution and Transmission Incorporated. We are the wires utility, and I'm here to present a little bit about the grid of the future. So jumping right into it. Why are you hearing from a utility engineer? I guess some of you may be wondering. Well, as the utilities obviously are very interested in this kind of the change that's happening. I work for a team called Grid Transformation, and I often get asked, "What do you mean by that? Are you transforming the grid?" And the answer is no. We are not transforming the grid. The grid is transforming as a consequence of changes in customer behavior. And so, from a utility perspective, we're really interested in understanding, how is demand increasing as people buy EVs, install EV chargers, buy ACs, heat pumps, and continue to increase the amount of solar generation that they're installing, in residential solar as well as commercial industrial, and also now with the introduction of battery systems. So there's a lot of questions around how to integrate these different resources and assets and loads into the system in a way that's really effective. And what this is driving is really a change from the traditional grid to customer relationship, where the grid supplied energy and the customer consumed energy, and the customer basically provided their metering information, and that was what the grid took back. But now the grid is providing information and power, and the customers are also providing information and power. And so the one-way relationship has really become a two-way relationship now, and that is the transformation that we're really interested in. So adding a little bit further context, I mentioned that I'm from EDTI, which is the Regulated Wires Utility, and we own and operate the distribution and transmission grid in the city of Edmonton. But we are not an energy retailer. The energy retailers are companies that you typically sign up with, and they provide the actual financial transaction for the consumption or generation that customers consume or produce. And so we'll talk a little bit more about sort of how energy retailers are going to play into this future scenario later. And of course, the customers are everyone here, including myself. We are the people installing solar and batteries and EV chargers and adding all sorts of different things that utility engineers like myself have to contend with. But of course, that's what we're here for, and we're here to support our customers and make sure that we install and integrate all of these different technologies and support our customers in a way that ensures that the grid is reliable and safe for everybody's use. So this presentation is really geared around energy storage, but what is energy storage? So it includes all sorts of different technologies, including batteries, flywheels, compressed gas, pumped hydroelectric, thermal storage, other types of storage as well. But my presentation today is really going to be focused around residential customers, and batteries are really the most accessible for the average residential customer. For commercial industrial customers, they can have a combination of the above, but really for the purposes of this presentation, we're going to be focusing on battery energy storage systems, or BESS. Then that begs the question, what is a battery? And the answer is really we're focused around electrochemical batteries, right? It's a chemical reaction that is generating electricity, and that's essentially what we're most interested in for the purposes of our conversation today. And a lot of you are probably familiar with lithium ion. Lithium ion batteries are used everywhere, from your cell phone to your EV to your battery that you're going to install after this presentation in your garage or basement. And there's also other sort of chemistries. Nickel metal hydride, lead acid batteries are the sort of typical 12-volt batteries that you would have in your vehicle. Whether it's internal combustion or EV, they typically always have a 12-volt lead acid battery, or even a newer technology, redox flow batteries, which are not really home scale at the moment. They typically have large containers of some kind of electrolyte that flows back and forth between the two sides to conduct the redox reaction that generates electricity. So all of these have sort of advantages and disadvantages. For example, lithium ion phosphate, or LFP, are very reliable and very stable, and relatively inexpensive, but they don't have the energy density of like an NMC battery. But an NMC battery is less stable and uses like really rare earth minerals like cobalt. So it's a little bit harder to build and more expensive. So pros and cons with everything. So let's talk a little bit about the advantages that batteries add to any sort of installation that you'd have. Well, we're at Solar Alberta, the solar show. So it makes sense to talk about how solar power is optimized. And really, this adding energy storage or battery energy storage is really the best way to optimize solar usage, because it lets the user or the owner determine when that stored power is going to be used. When you install a solar system without a battery, the sun shines and you're generating, and when the sun goes down, you're no longer generating. But now with the battery system, you can charge up your battery and choose when to use that stored power, whether it's for your own use or for export onto the grid. It provides a self-consumption backup in the event of a grid outage. They are relatively small and lower price compared to other energy storage solutions. And the technology is advancing very, very quickly. Battery technology has changed drastically in the last 10 years, driven by things like EVs and all of the funding that's being put into decarbonization around the world. And it allows batteries allow customer participation in demand management and demand response programs because, again, they give you the opportunity to really control the solar energy that's being generated in a really conscious way. So of course, with the pros come some cons, and the technology is relatively new and it's advancing quickly. That was a pro previously, but it adds a question as to the best time to invest. A lot of customers are going to want to buy batteries, but there'll be there is a certain amount of analysis paralysis as to how long should you wait? You know, the battery technology advancing so quickly, eventually the technology, you might buy a battery and then find out, oh, you know, like they just came out with something really cool, really new, really inexpensive, and I've already invested thousands of dollars into this asset. So what do I do now? The export grid export batteries and regulatory hasn't really caught up yet. So because the technology is so new, we're still working out, you know, the optimal size and capacity requirements for individual battery installations, especially at the residential level. So there are potential impacts, of course, in an unsupervised case where everybody gets a battery and they control it themselves without any sort of awareness or integration with um, like an aggregator or the utility. That lack of coordination could cause charging and discharging impacts to immediate neighbors and upstream assets and utility infrastructure. And at the moment, the financial incentive is a little bit weak. There isn't a lot of incentive in terms under the existing sort of microgen regulation to engage in, you know, like an energy storage for the average residential customer. But we can really turn some of those disadvantages around if we look into the concept of virtual power plants. And a virtual power plant is essentially something that consolidates all of these different types of distributed energy resources, and it can include solar panels, batteries, EVs, and even smart home devices like smart thermostats or smart water heaters, and essentially aggregates all of those devices into something that collectively is like much bigger. So you go from having an individual customer that has a 5 kilowatt battery, for example, to a group of customers that have a 500 kilowatt battery or you know, a 1 megawatt battery, and that really changes the game in terms of the impact of the system, as well as potential financial benefits that the customers who are participating could get out of that. And the virtual power plant is centrally managed. So now you take all of these resources that would otherwise have been totally uncoordinated, and you're able to coordinate them in a really effective way to benefit both the grid and the customers that are participating. So I've talked a little bit about some of the benefits of virtual power plants. They allow greater impact and market participation for customers, but they really, really can improve grid resiliency. And grid resiliency is the idea that, you know, we talk about reliability, of course, like how often is the grid up and running, and reliability is quite good. But in terms of the resiliency, it's really about it's a qualitative measure about how well the grid is performing, and virtual power plants can help with that performance in terms of balancing supply and demand, peak shaving, providing voltage support and frequency regulation. And it's doing that by basically coordinating these batteries. It improves the battery coordination, improves the optimization of solar generation. And we've seen really good success with these types of technologies with virtual power plant implementation in other jurisdictions. Of course, there are some challenges with virtual power plants. First and foremost, aggregating all of these different resources requires visibility and control of customer equipment, and customer enrollment could be a challenge because you have to convince customers to willingly give up or share their control of systems that they paid for and installed basically for their own use. So that's actually quite a big potential challenge. But the other big challenge is regulation. Regulation around virtual power plants is still, just like with batteries, it's being developed. And the reason for that is because the concept is relatively new, but also because the technology to implement the concept is relatively new as well. So regulators and utilities are, and even aggregators are still working through a lot of these hurdles to define all of these requirements. And of course, controlling and monitoring all of these different resources in the system requires really robust communication infrastructure, and that communication infrastructure has to be well defined, and the requirements around it have to be well defined, which is still in progress. And of course, anytime you have communication to especially this many different assets, you have to worry about cybersecurity, because there is, of course, a risk of some malicious party getting access to a virtual power plant and causing, some kind of sabotage. And cybersecurity is a big issue for utilities in general. So that's a major issue that needs to be contended with as we go along this journey. But what I want to talk about next is really the what we consider to be the bee's knees, sort of the virtual power plant, and that's a virtual power plant that's fully integrated with the utility control system. So here at EDTI, we have an advanced distribution management system, or ADMS, and it allows us to have very good visibility and control of the electrical grid in real time, which is pretty cool. But if you have a virtual power plant provider, and a virtual power plant provider is essentially the entity that's aggregating all of the different customer resources. So they could also have the energy retail side, or they could be a third party to the energy retailer, and the energy retailer would just act as the financial transaction authority. But by combining this sort of virtual power plant, which is a sort of a grid edge DER management system that has really good awareness of the customer side of things, with the ADMS of the utility, which has really good awareness of the grid and the grid needs and the grid con, con, condition, then you combine those two sets of information, and now you have really like almost perfect awareness of everything that's going on in the system. And now you can really optimize how you're deploying all of these different resources from the utility perspective. And now, because there's really good integration with the utility, the virtual power plant aggregators can also start like proposing services to sell, whether it's voltage support services or frequency regulation services or peak shaving services. Now we know how much of the peak they're going to shave, or that we need them to shave. Now you can evaluate what that service should be worth. And so we can enhance grid stability. We can produce some cost savings on the utility side by using such a powerful resource like a virtual power plant. We can actually potentially reduce or defer the amount of capital investment we need by increasing the utilization of the existing infrastructure. We can have greater market participation by the customers, and we can have greater impact on emissions reductions, because now this virtual power plant actually discharging the batteries could offset the need for really expensive peaker plant operation, right? And peaker plants are typically less efficient from a emission standpoint compared to other types of generation. And so that's a way to help decarbonize and reduce emissions as well. So really, this is kind of like, this is what we're pushing for. And we've seen it really effectively implemented in some projects. So I'll call out Rocky Mountain Power in Utah. They have a fully implemented virtual power plant with over 2,000 customers, and they're getting more customers enrolled every week. And they basically fully utilize the customer batteries to do voltage support, frequency support, and their customers are so excited about this concept that they don't even want any sort of like they like own use backup reserve. They want the utility to use all of that capacity because the utility is paying for it. And so there's a really good financial incentive on that side. Now, Rocky Mountain Power is like a vertically integrated utility, so they have full control over that aspect. In Alberta, our market's a little bit different. We have the regulated wires business, and then we have all of the energy retail work that happens, which actually does all the financial transactions, as I mentioned before. So in Alberta, we are working on some projects. So Landmark Homes has partnered with the same virtual power plant provider as Rocky Mountain Power to basically install batteries in 100 homes in Edmonton as a part of an Emissions Reduction Alberta supported project. And we are also a partner on the project along with the city of Edmonton. Sonnen is the company that's doing the virtual power plant aggregation, and Solartility is the energy retailer that is adding a fairly unique financial model to the implementation, where they actually expose the customers and the virtual power plant to the wholesale market and take advantage of that volatility in the wholesale market to increase the financial incentive for customers to enroll and participate. And that's a really really interesting project. We're working on it. We're a year in, and we're in the implementation and integration stage. So on the EDTI side, we're integrating with our ADMS, and on the Landmark Home side, they're building more homes and installing more batteries to enroll them into the virtual power plant. And then the other project that I want to call out, another emissions reduction Alberta project, is Derby is the company, and they're doing a more level 2 EV charger project, focus project, pardon me. And the idea here is that they're going to optimize their customers' EV charger performance for the same financial sort of incentive. They've also partnered with the energy retailer Solartility to do the same sort of like wholesale market exposure, but here it's really about optimizing their charging behavior to save as much money as possible for the customers. And that's a 10 home pilot that we're also in the integration phase on. So these are real projects. These they're in progress, right? And we expect to see really good results out of them. And we're very excited to be able to develop this skill set, develop this tool set, so that we can show our peer organizations in Alberta as well as in all over Canada that the concept of virtual power plants, especially utility integrated virtual power plants, are the way of the future, and they're going to add value to utilities and customers in partnership. So that's the end of my presentation, and I will go ahead and pass the mic to Gabriel. Thank you so much.
Okay, so I'm going to discuss what utility scale energy storage is, so different uses for it, how it's being implemented in Alberta, and the advantages that it has when paired with solar power. And we'll end by sort of talking about what this all means for Albertans. Before we get into it, I'm going to introduce Solus Energy. We are an engineering consulting firm. We have been in renewables for over 15 years, and we have experience in the full life cycle of renewable energy projects, from feasibility studies through development, construction, operations, and even repowering of projects. We also offer a broad range of services in other fields, such as hydrogen, zero emission mobility, greenhouse gas quantification, for example. When we talk about utility scale or grid scale energy storage, we are essentially talking about larger projects than you might see on the residential or commercial side. This picture here shows the biggest project that we have worked on at Solus Energy, and it's actually the biggest battery storage project in the world as well. It's 3.3 gigawatt hours of energy. For a sense of scale, it has about 330,000 times more energy in it than a typical home battery system like this one here that could power the average Alberta home for about half a day. These energy storage projects can be paired with solar or wind generation, or they can be on their own, selling and buying power to and from the grid on their own. And really, they can vary a lot, and they can have many different purposes and depending on the technologies. So let's take a look at those. The first group of applications for energy storage is ancillary services. And ancillary services basically mean supporting the grid and helping to keep the grid stable. So that can include reacting quickly to make sure that the supply of electricity always matches the demand for electricity. It can include providing backup power, maintaining a constant voltage and frequency on the grid, and even restarting the grid after a blackout. Some energy storage technologies can respond very quickly to changes on the grid, such as lithium-ion that Ozair had mentioned earlier. And when we're talking about grid congestion, in some cases, if a transmission line is nearing its limit of how many electrons it can carry, energy storage can hold on to that excess electricity and feed it back through the grid later when there's more capacity on the line. So in that sense, it can help reduce the need for new transmission upgrades and reduce the cost onto the consumers. And finally, on top of all that, energy storage can just allow more renewables to participate on the grid, making it a cleaner grid, especially in a system like Alberta's. We'll talk a bit more about that later. So there's a lot of different technologies that can be used at the utility scale, not just batteries. But one way to categorize energy storage systems is by their duration. So say you have a 200 megawatt hour system that has 200 megawatt hours of energy, and it can output that energy at a rate of 100 megawatts. So you do 200 megawatt hours divided by 100 megawatts, you get a 2-hour duration for that storage system. So that falls into the category of short duration. And short duration can include batteries. It can also include flywheels. The one in the picture here is a flywheel in Ireland that that has a mass of 120 tons, and it spins at 3,000 RPM, but it actually has a discharge duration of 8 seconds. And it could also include supercapacitors. The next category is medium duration. And typically you'll see batteries in that category, both lithium ion or other chemistries such as redox flow. And that's 4 to 10 hours. And then beyond 10 hours, we have long duration storage. And that can even be seasonal storage. So when you have high production of solar over the summer, you can store it for the winter, for example. And those technologies, you might see some, because it's such a broad category, you might see some redox flow batteries, or even at its limit, lithium ion systems could last over 10 hours. But you also see stuff like pumped hydro storage or compressed air energy storage. Well, you're going to pump the air underground under high pressure, and then when you release it, it spins a turbine at the other end to produce electricity again. So what do we have right now in Alberta? As of today, last I checked, Alberta has 10 standalone battery energy storage systems on the grid. And they total 190 megawatts of capacity. And that's the power. And I believe most of them, if not all of them, are 2-hour systems. So they have double that number in megawatt hours. They're mostly used right now to offer ancillary services that I talked about earlier. So responding quickly when the grid needs them to help keep it stable. And the image here is actually the first standalone battery energy storage system that was built in Alberta back in 2020. It became operational, and it's owned by TransAlta near Pincher Creek. So what's in Alberta's future? This chart on the left is from the Alberta Electric System Operator. It's from their connection project list. So it's basically a list of all the projects that want to connect to the grid. Doesn't mean they necessarily will. There's a lot of challenges with developing a project, but this is everybody who's trying right now. So in total, there are 34 gigawatts of projects on this list. And we can see that there are 3.2 gigawatts proposed for battery energy storage systems, BESS, 640 megawatts for compressed air energy storage, and almost half a gigawatt of pumped hydro storage projects proposed. On the wind side, we have 4.5 gigawatts for wind projects alone, but then 1.1 gigawatts for wind paired with storage. And then when we get to solar, that proportion in terms of total capacity of solar and storage is actually larger than the one for solar alone. So even though there are more projects proposed for solar only, there's more capacity being proposed when paired with storage. Why could that be? I think I have a few guesses. So these are my main guesses. There's a lot of advantages of pairing solar farms with energy storage. First off, it can really help regulate the output of the solar project. So when production is in excess or when there's congestion and the wires can't carry all the energy and they're trying to curtail or limit the solar production, the energy storage system that's paired with the solar system can store that energy and release it later when the production is lower. This also allows solar farms with energy storage to stand out. So it gives a competitive edge to those farms because every solar project is going to be producing pretty much at the same time. And that's a lot of supply onto the grid. But if you can sell later when there's more demand and there's a greater need for ancillary services or for just electricity in general, you can potentially make more revenue. So it's a great advantage on the utility scale. And the third parallelogram here is an advantage that is still being defined right now. So the ASO is making a lot of changes to the market structure, and they're going to implement a way for power producers to commit to producing a certain amount of electricity a day in advance. Since it's a little more difficult for solar to exactly predict the production that they're going to have the next day, energy storage can help these solar projects to participate in this new market where they have to have a confirmed amount by the next day. So what's in it for Albertans? What does all this utility scale energy storage mean? So by allowing more renewables on the grid and by reducing transmission congestion and also by reducing the need for peaking plants, as Ozair had mentioned earlier, it has the potential to lower the costs for Albertans in general, for consumers. It can also help reduce the grid's carbon intensity by allowing more renewables onto the grid. And overall, it can increase our electric system's reliability. So that's all I had for you today. Thanks for listening. Thanks for Solar Alberta and Greengate for hosting and sponsoring respectively. And if you have any questions for me or for my team, please reach out at info@solacenergy.com or at 403-454-9463. I'll now hand it back to Heather. Thank you.
Oh, wonderful. Thank you so much, you two. Those were great presentations. I feel like we learned a lot today and definitely asked the right folks to present, so thank you. Okay, welcome back on screen, Ozair. The Q&A box is lit up. So just a reminder for people, we're going to use the most upvoted questions. So use your thumbs up because we're never going to get to all of these. So we're going to take from the top. Anonymous attendee is wondering, I always love that, has EPCOR considered providing incentives or rebates for batteries that can connect to the control system if it can help the grid run better? I mean, BC Hydro and Nova Scotia Power provides rebates for batteries. Why not EPCOR? And I suspect NMAX folks are wondering the same thing, as are the ATCO and Fortis folks. Come on, we're just trying to help you out here, Ozair. What do you think?
Yes, very, very good question. And it has to do entirely with the regulatory environment. So in the case of BC, I'm not sure about Nova Scotia Power, but BC Hydro is definitely a vertically integrated utility, which means that they control everything from top to bottom. Like they control energy retail, they control the wires, they control a certain amount of generation as well. And so for them, they have the mandate and the ability to provide those incentives, and it's like there's a regulatory framework around that. For companies in Alberta, especially wires companies like EPCOR, we don't have the regulatory framework to basically incentivize that kind of stuff. We could like there might be avenues, but it's like I said, this is a very new technology, and so the regulation around it is very, very, it's still catching up. And so we don't have the same options in terms of like incentivizing and subsidizing these types of things that a fully vertically integrated utility would. I use the example of Rocky Mountain Power in the US. They're a fully vertically integrated utility, and they do subsidize the batteries that they're installing for their customers. But that's because they have full control over that whole framework.
Right. Yeah, in Alberta, it seems like if you want to get any of that going, it has to be the government of Alberta or the various municipalities providing the incentives. That seems to be the main mechanism that
Hmm.
can be used locally in our political system. So no, I appreciate that. I wish EPCOR could just could do that, but because I know
Us too.
you
Us
probably would
too.
have done it 10 years ago if you could.
Yeah, and
Um,
there is a little bit of legislation around utilities and batteries in particular, and their uh, Bill 22, I believe, outlines a lot of stipulations on where utilities can invest directly into batteries, like wires utilities, and so there's quite a lot of rigor around what we'd have to prove in terms of like need for the grid and all that stuff. But I will add just a quick note that on this past Friday, the Alberta Electrical System Operator, the AESO, they released their long-term plan, and in that plan there is a provision for them to direct transmission utilities to install batteries, and so
good.
there is a framework, there is a push top down now to support this technology.
Yeah, so they might decide to use the stick approach with you folks instead of the carrot approach.
Well, I mean, a direction is a direction. Like we would just do it then, right?
Yeah, exact. Oh, we have to do the thing we want to do.
Oh no.
No, that's good. That's good. No, I appreciate that. Thank you for your candor there, and I know there that it is very confusing that Alberta is so different from every other province in the country. Another question here, ooh, very popular question. Do you have an estimated timeline for when we might expect to see time of use rates in Alberta? We have had this question probably every session this week, and I kept telling them, wait for Thursday. We'll talk to some battery folks. Any crystal balling you want to do? Ozair, you're probably not allowed to do as much crystal balling as Gabriel. So maybe I'll go to you, Gabriel, and see if you want to do the crystal balling, you get a little more freedom when you're not so regulated.
Well, actually, I don't have an estimated timeline, unfortunately. I'm aware of pilot projects. I know that ATCO was trying it out in a few select regions maybe a couple years ago, but I don't have any more insight than that. Sorry.
Yeah, no. Similarly, we just dream. We dream of a day. How about you, Ozair? Any idea? Are we talking 10 years out here? Are we talking 5 years out? Is this dream just never going to come to fruition here? What's your level of hope?
Uh, so I'm gonna probably I might get in trouble for this later, but I would say so. I wouldn't care to speculate on when or if we're going to get time of use rates. I think we are seeing we're watching other jurisdictions very closely in terms of like the rate structure and the impacts of time of use rates. And I think we've seen in other jurisdictions that time of use rates they start out like really well, but it actually as you start running into like load problems, those load problems don't go away. They just get shifted to like later, whatever the time of use is incentivizing. So that's one aspect. But the other aspect is really also a question of technology availability. So time of use rates really require access to like AMI, advanced metering infrastructure, to provide the data and to provide like really high fidelity data to show that customers are behaving and following the time of use rates, right? And that is something that is still like utilities are still getting AMI, right? Where people in the city of Edmonton are very fortunate, I would say, because EPCOR installed AMI like back in 2015 or 2017, and we've been running AMI. Like we're looking at the next iteration of our AMI project, but not every DFO in Alberta even has AMI fully deployed, right? So that's like without AMI, time of use is like you need the technology before you can start developing a rate structure for it.
Yeah, and I was alarmed to discover there are some places in the province where they still don't have bidirectional meters sort of automatic. You have to, once you get your system hooked up, then
Mhm.
they literally have to come out and switch your meter. And that just felt kind of old school because I've been a little bit spoiled here. We switch it on in Edmonton oh, it is bidirectional. We don't necessarily have to go through the same arduous and painstakingly slow process that other areas of the province are going through. So a little patience there, I guess. It's sad. My dad likes to troll me, hey? So he from BC, he'll send me his time of use benefits, and he just thinks I will be so excited, and he doesn't know that I'm like crying myself to sleep at night. He probably doesn't realize he's trolling me. He just thinks he's sharing the excitement of time of use pricing. Anyways, okay, Bob's here. And thank you for coming, Bob. You've been so dedicated this week, by the way. During a brownout, which happens where I live, can the supply authority access my stored energy when I want to store what I've got? I.e., stored energy isolated from the grid. Forgive me for my ignorance. Just so you two know, we've got lots of amazing farmers on the line today who are all getting ready for their presentation tomorrow. And so, yeah, this person is obviously coming at us from a place where they don't have as much reliability as we do here in the downtown Edmonton. I guess, Gabriel, I shouldn't speak for you. I think you're in Calgary, aren't you? But I assume you're not getting as many brownouts either as poor Bob. Yeah, would either of you be able to comment on that? Question here, can the supply authority access my stored energy when I want to save what I've got? So would they have that system? I guess what you were talking about there, Ozera, is sort of the ability of EPCOR to kind of access the VPP system. That's pretty new age, isn't it? Right? Like you guys are doing that here in a pilot stage. I don't know that Fortis or ATCO would have that ability in rural Alberta right now. What are your thoughts?
So it really comes down to the agreement that you have with the supply authority and whether or not you have a grid export capable battery system in the first place. So if you are familiar with like the Tesla Powerwall, those come sort of like software limited not to do grid export. But that software limitation could be removed if you were to want to use it for grid export, but then you would need an agreement with the authority that you're connected to. So in Edmonton, that would be like a interconnection agreement similar to what we have for our solar customers. Who they apply with like a microgen application, and then they go through the process of review. And the vision that we have is that if we are signing up a customer for use of their battery and they're giving us access to the battery, then it would be stipulated in very clear terms that this percentage of their state of charge is for them, and this percentage of their state of charge is for grid use,
Mhm.
right? Or for virtual power plant use, whatever the case may be. So unless they have that agreement in place, nobody should be able to access that resource because you haven't agreed to it. And if it's not grid exporting, then it's not really an issue in the first place.
Yeah, if it's not connected. I will say a lot of Solar Alberta installers have become quite knowledgeable about batteries. And if you are on our directory, you can actually go through our directory and see which of our installers are knowledgeable about batteries. And they should also be able to tell you whether your local wire provider is able to enter into that type of agreement or not with you, and if they're willing to. So definitely pick some of those brains from our directory because, obviously Gabriel and Ozair can't tell you about every specific region of the province, but our installer members are actually working all around you. So they will be very competent and able to help you navigate some of those systems. And that's really why we pay them the big bucks, right? Is to help us navigate. So, and if you're really struggling and you're trying to do something really bigger scale, then definitely we also have members like Gabriel's company and others who do consulting on sort of some of those bigger projects and things. So you can talk to members of ours about both the small scale pieces, but also some of our consulting members can kind of coach you through those various, we like to call them in Alberta red tape. I like how Ozair, you never use that language. We do you have an agreement? Meaning, have you gone through all the red tape? But we do have a lot of professionals in our directory who are essentially red tape advisors. So you want to hit them up. All right, anonymous attendee is very popular today. So great questions from anonymous attendee. How exactly does someone benefit financially from having a battery in their home when they pay and sell electricity for the same price in Alberta? So yes, demand side management, like all these things we dream of, we don't have that right now. So is it really, I mean, you talked about some of the benefits of there, but at this point, do you think the benefits outweigh the cost yet? Or where do you think about that?
Uh, yeah, so I mentioned in my presentation that the financial incentive to buy a battery is kind of weak right now, because of the existing microgen regulation. You buy and sell energy exactly as the the individual mentioned. It's at the same rate, right? So the microgen regulation is really designed to get you to that net zero stage. It's not really designed to get you past that. Um, I have to be very careful here as a regulated wires utility. In turn, I can't point at any specific companies that might be able to get you around that. But I will call back to my slide deck. We talked about the virtual power plant projects and the unique financial model that we're working with in terms of Landmark Home and the partnership with the City of Edmonton Solar Utility, and the exposure to the wholesale market is kind of a new thing. And I see there's some notes in the chat there about the wholesale market and hourly pricing. So that is one avenue that's being explored right now in terms of like potentially providing a stronger financial incentive. But yeah, 100% agree that yeah, under the existing microgen, it's pretty tough to justify the cost of a battery installation.
Yeah, that's been a challenge we've been struggling with ever since I started here. Is our members are ready to roll. They're ready to do the installs, but the incentives aren't all there yet. And I know they're coming. It just feels like they're coming very slowly. That said, when I saw the registration for this event, which skyrocketed in the face of the threat of tariffs from the US, I discovered that there is one more incentive that a lot of Albertans are thinking about right now, and it's not financial. It's energy security and
Mhm.
energy sovereignty. And so when you look at that cost benefit analysis, a lot of people are thinking more and more today about the benefit of maybe having a little bit more control over your own electricity. And so I think that the equation has shifted a little bit this week. And what maybe wasn't once as economically feasible for a lot of Albertans is suddenly becoming maybe a slightly higher priority for folks. So that was a fascinating shift to see in the registrations, which I think doubled in the last week. So fascinating to see the cost benefit analysis and all the different things people put in there. But yeah, nice also to see innovation on sort of the retail side of things. I think that that's wonderful to see. And as you mentioned, a lot of that has to do with how smart our meters can get here. So smart grid folks, I think we all really appreciate their input. Gabriel, anything to add on that topic?
Yeah, just as I mentioned in my presentation as well, just the existing standalone storage projects at the utility scale in Alberta are not making their money from arbitrage right now. They're not making their money from buying low and selling high. It's maybe over 90%, if I remember correctly, ancillary services. So by really that there's not really a market for it right now yet.
Yeah, yet. Everybody's getting ready though, aren't they? And I will say one thing that has been stable, despite all the political turmoil in Alberta, consistently, everybody has been talking about demand side management and creating some of those incentives. They haven't done it yet, but there has been consistent conversation about that ever since I started at Solar Alberta 5 years ago. So it's been really interesting to see that that conversation persists. It doesn't seem to matter where you are on the political spectrum. And so that I do take some comfort in that. Oh, Blair has a popular and lengthy question here, so get ready. Ozair, thanks for your talk. I know a bit off topic from storage, but you talked briefly about upgrading the grid. I installed solar at our home and was restricted to install what would give us net zero electricity over the year. Yeah, that's the microgeneration regulation he's talking about there. I know that in other provinces like BC, there are not such restrictions. I would have liked to install a larger array to be ready for further electrification in our home in the future. A larger array would have also allowed better coverage in winter months. Can you comment on what happens with excess electricity that goes back to the grid and what is involved in upgrading the grid? So I guess the reason we're restricted here and the reason we're told we're being restricted is because the grid can't handle what we want to give it. It doesn't have the capacity. It doesn't have the capacity to receive all of the love we want to share, all of the electricity we want to share. So I think that's one of the justifications that's often used for the cap on microgenerators in Alberta. And I've even seen that for small scale generators. So I've seen that two megawatt folks have been turned down because they were told by Fortis that there's just not, they can't receive what they have to offer in that part of the province. So that just goes back to this question. Can you comment on what happens with excess electricity that goes back to the grid and what is involved in upgrading the grid? Big questions. So maybe touch what you can there, and Gabriel can touch on some of those macro pieces too.
Sure. Yeah. Very. We could do a really deep dive. My background is planning, and so that's literally answering this question was my job. And so, but it's a fairly deep dive into like really technical stuff. But I'll try to keep it high level. So the challenge with accepting excess generation on the grid is that if the load isn't there, then that electricity flows upstream. And depending on what infrastructure you have upstream, it may or may not be designed to receive electricity in the first place. I'll give you like an example of a substation transformer that converts from the transmission voltage of like 240 kV to the distribution voltage of like 15 kV. There are some transformers in the system that if you if you inject power on the low voltage side, it will literally overheat the transformer and burn it out. So that's an infrastructure decision that was made like a long time ago when there wasn't nearly enough generation to make that a problem. So not every transformer is like that, but that's an evaluation that the utility has to do whenever this kind of situation comes up. The other sort of challenge is that with solar specifically, there's a big drop off when the sun goes down, right? So in the wintertime, that's like, 4 o'clock, it gets super dark. And so in California, they already experience what they used to call it a duck curve, but now it's so extreme that they call it a canyon curve because you just fall off a cliff in terms of your generation. And now you have to have spinning generation or battery capacity spin up really, really fast to accommodate that big dip in generation or in supply because the demand is actually increasing really fast during that like 5 to 10 p.m. Time period. So that transition is very very abrupt. And to smooth that out, energy storage is a really good solution, right? Because you can stage that as the solar generation tapers off, you can stage that transition with a little bit more input from the energy storage, which is where like it's really big advantage to have energy storage. But without that energy storage, it becomes really challenging to manage that excess generation that was like supplying when you didn't need it, right? And potentially like heating up assets that aren't designed for that level of power flow in the opposite direction. Um, and then yeah, suddenly that that's abrupt transition that has to happen to spinning generation or more traditional generation that happens when the sun goes down. So that's like very at a very high level the balance that is trying to be maintained by the utility. In terms of, yeah, and I can't comment too much on the microgen regulation and that net zero aspect. Yeah, there's definitely some truth to the idea that the grid can't handle it, but it's the grid. There has to be a certain level of penetration for that to be the case. But of course, if everybody like oversizes their solar installations in the hope of in their that their future going to install like this, and this, there is provision. At least EPCOR gives provision that if you can prove that the load is coming, whether you have like some signed agreements or you have receipts or something, you can upsize your solar based on that. But you can also amend your microgen application by submitting an amendment and increasing the size that way. So you wouldn't necessarily get it in the first iteration. You could add to your solar system piecemeal over the years as your load increases. So there is a bit of an option there to accommodate that, but we just want to make sure that the load and supply is as balanced as possible.
Yeah, and I appreciate you commenting that on that, and I understand that the fear is less around the small micro generators. So a lot of the people on the line today might have a 7 kilowatt system, and the wire providers aren't scared of you. But micro generation goes up to 5 megawatts in Alberta. So that means there are large micro generators who, if they were allowed to install as much as they wanted, they might actually make it impossible for any of you little folks to operate. So, for example, if West Edmonton Mall decided tomorrow to throw up a solar system covering their entire mall and all of their parking lots, nobody in West Edmonton would be allowed to put up a little tiny solar array on their roof because there's no way EPCOR could handle all of that at one time. And so really some of those restrictions allow for a little bit more of a distributed solar access to everybody, so that not just one big player takes up all the space on the grid. For this reason, if you are agitated by the microgen reg, on our website, we do have a support us section where you can advocate with us. And what we're calling for is an amendment really to the microgen reg to allow anyone on a 200 amp service or less to be able to max out their roof space. And so that's not scary to wire providers. We're so small that it's pretty inconsequential. What will probably make them lose sleep at night is if it goes up above those folks. And if we're talking about large microgenerators, then all of a sudden you're going to have to see a lot of the adjustments to the system. So we're trying to find a balance there, and I think everyone is. And my understanding is when this microgen reg was first drafted, there was this sense that every one of us would adopt solar immediately, and then we would have a problem. But unfortunately, that hasn't been the case. And right now, even though we have 30,000 homes and businesses in the province with solar, which is great, by the way, and we are like superior to every other province, by the way. So we're doing great, but we're still not really a threat to the system. So that's why we're advocating for that shift to the microgen reg. So you're welcome to join us in that advocacy. But I wanted to end today by just thanking our presenters, neither of whom probably want to touch wholly on the advocacy topic that I get the pleasure of diving into as a non. I get to wear that hat today, and you guys get to wear the professional, nonpartisan, apolitical hats. And I want to thank our extremely professional, apolitical, wonderful presenters who happen to know a heck of a lot about batteries for educating us so much today. This has been incredible professional development for me, and I'm sure for over 100 people who joined us today. So thank you very much for taking your time out of your busy schedules. Also want to thank the amazing audience. What great questions. I can't believe we didn't get to all of them. I hope you grabbed that contact info from our presenters on their slide decks, so that you could hit their offices up at some point for additional questions. And you're always welcome to message office@solaralberta.ca anytime. That's why we're here. If I don't know the answer to something, or if my staff don't, we'll probably pick some brains around the directory, because we've got a lot of incredibly smart members who can advise us as well. So hit us up for all those great questions. Thank you again for Greengate to sponsoring this session, and to our staff, of course, for pulling us all together. So have a wonderful day, and I hope to see everybody tomorrow morning. We've got a Deep Energy Retrofit Guide with Peter Emerangen. So if you don't have $150,000 for a full deep energy retrofit, he's going to be talking to us about how to sequence that retrofit so that you can afford it over time. So that's our morning session. And then, of course, for all you farmers who have waited patiently all week, we're going to be doing solar on farms at lunch tomorrow. So can't wait to see you there. And thanks, everyone. Have a great day.